Wednesday afternoon, Unit 1 assessment review. You take it and go so that if it's a reflection, it should look like it's looking in the mirror at itself. Like in that movie, that was a scary movie, Silence of the Lambs. Yeah, the guy's in the mirror like, I love me. Oh, that thing is crazy. I can't say the real words if you haven't seen it. It's worth seeing.
What? What is it?
Down. They just flip it straight down so that it looks like this. This is the wrong answer. Don't put this. Click, click, click. There's C. Oh, by the way, the first time you do it, it gets 1 prime. The second time you do it, it gets a double prime. Where you were A. This is wrong. If you put it on your test, it's going to be wrong. Why is this wrong?
The A is in the wrong place.
Yeah. In order to be a reflection, you have to be the same distance away from the line and at a perpendicular thing. Right, that's going to be correct. So I'm going to do the right answer now. I just want somebody to see like, oh, shoot, I did it wrong. C is this far away from the line. You have to make a plus sign. What does he mean you have to make a plus sign? If you did it right, you will see something like this. B, I'm going to make a plus sign. It'll wind up the same distance away. A, I'm going to make a plus sign with the line of reflection. About the same distance away. Now again, with your tracing paper, you don't have to measure it. You're going to flip it over this line. You're going to take the tracing paper, draw it, draw that line, and blank, when you flip it over, it'll be perfectly where it should be. C, make a plus sign with it. This is just so you know, am I in the neighborhood? If there's no plus sign from C to C prime, double prime, A to A double prime, you know you did it wrong. The good news is, each problem number 1, has 4 pieces. You need to get 2 of the 4 pieces correct. If you miss 2 of the 4 pieces, you're okay. So basically you need to get 50%, which is a nap. So you need to fail because I messed up. Where is it? Good eye, good eye, good eye. Am I still recording? Yes, I am. You're what, B? B prime? B double prime. When you go home tonight and somebody says, what'd you learn in school today? And if they don't say what'd you learn in school today, say, hey, ask them what I learned in school today. You say, what'd you learn in school today? B double prime. And they'll say, what is that? You say, you should go to school. Now, if it's your parent, you might get in trouble. It's going to be all saucy or whatever. Just be like, you know, you should go to school. You dropped out, remember? No, don't say that. Don't say that. Go to your room. I don't want to room. I live in the... All right, here we go. So there it is. Reflection. You got to get it right. And if you need to know if you got it right, draw a line, see if you make a plus sign. If you make a plus sign, you did it right. No plus sign, you didn't. Here it goes. Anybody know what this is called? What the shape is called? Oh, I'm sorry. When I graph it, yeah. It's a parabola. It's a U. I'll do click, 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 click. It doesn't really matter how close you come to it, just that you know it's a U. Hey, Thomas, reflect this U over the x-axis. In other words, it's stuck to the x. It just falls down. I wish I could animate it that it just falls down, but I just reflected it. How do I know it's reflected? If I drew a line, it would make a plus sign from U to U. See the plus sign right there? Okay. That's me sketching it. Let's see if I can do it. Technically, I think you can do it with your, what's the thing called? Your graphing paper or your tracing paper. But again, a sketch, I would take it. Here comes the second version of it, which is on the next page. This guy right here. All right, let's just do it. Here it comes. In graphing, if there's a number at the very end of the original equation, y equals x squared, it just tells me you take the original picture and slice it up 3. Okay. So make a U now at 3. So there's the 3, there's the plus 3, no big deal. How do I reflect L over the y-axis? Dang it. You know what? I'm going to reflect it over the x-axis because I think you may see that later on. I'm trying to scratch out the x, but now that's an x, so why would I put an x above that x? And I'm like, what? How many x's? All right, so let's put x-axis. What's going to happen is this is the x-axis. This thing, where since it started at a 3, when it goes, boom, it's going to fall down here at a 3 as well.
What is that?
Just like a U. But how can you tell it's reflected? is the same distance away from the line of reflection. In other words, you're 3, 1, 2, 3. Okay, 1, 2, 3. That's good. How about you? You're about 4. 1, 2, 3, 4. 1, 2, 3, 4. If you use your eyes, you squint a little bit. It's at 4. All right. All right.
So why would you have my first time?
Say it again. Say it again.
Why would be like?
Yeah. Why? This would be weird because to reflect somewhere, why just would flip like that? It'd be the same exact picture. In other words, this side of things would jump over here. This side of things would jump over there. But since they're all the same distance, it would look just like that. So it's a bad problem. Yeah. They'll do something more like this where it's obvious. They won't do that thing. Pause.
Where did you get it?
Did you draw the line of reflection? It's like, I don't know. Look, flip. The next one.
Oh.
Draw the line of reflection. You didn't do it? Or did we draw a line of reflection? Grab a highlighter. And draw the line. Oh, draw it in pencil first. Compare your picture with someone else's. If it's the same, then use the highlighter. If it's different, you all decide what's the correct answer. For this one here, draw the line of reflection, please.
Wait, I
Oh,
found.
it's
So
cheating.
basically,
Hey,
you
who's
just
that
trace it
kid?
and you put it on this side.
No. You're going to draw a line. A line of reflection.
Oh, okay.
Who's that in your other class?
Can't think of the name right now.
I don't know.
Can't think of the name. Daddy Hernandez, what? You going on the table?
I
don't know where else.
Oh,
Like
no.
this.
Okay, I'll draw it. This is a hard one. Oh, no, let me find out. The mirror always has to be in between. And how do you know where in between? In this case, of course, equidistant. I don't know if I used that word before. The same distance on either side. Anybody know what the formula is for this line? You'd be impressed if you know it. Not many people do.
Why? Oh, wow.
Yeah. Did I say that or did she say that? Or did you know that from somewhere else?
Brian.
Brian? You got it from Brian? Got it from her?
Brian, tell me about.
Yeah.
Brian.
Good work. All right, I'll mention Brian and
Call Brian.
all right. We already we got it, but I'm going to tell them that people knew it because of him. Yeah.
Yeah, because he popping.
He's popping.
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 Yeah.
Can one guy say that to another guy? Popping.
He like, Alexis said you a popping teacher.
You a popping teacher.
Just don't say it's
So
you.
Brian, boo. Lexus, she's like, boo, popping. I'm like, what? Like Mary Poppins? There we go. Did Marco Strong. I heard it before. I ignored it so I wouldn't mess it up.
recording.
Then I took it from him so I could mess it up.
You're recording.
Yeah, I want to. I know. So that the people who watch the video who weren't here will understand why the green line is not the answer. What he said before was the answer, which was
Why would you write that down?
because I'm popping. Because it doesn't reflect. If it doesn't, if you pose it like a book and it doesn't fold onto each other, then there is no line of reflection.
So there's no line.
Yeah.
Then why would you do that?
You gave us false information.
Because I'm popping. Circle this phrase, sequence of transformations. It usually means that you have to have done something twice. There has to be two moves. It can be the same move twice. In this case, let me see what the move is that I would think. I read yours and I felt like I was okay, but maybe I didn't focus enough. If I were to flip it this way and then flip it down.
You know this one.
If I had paper, I'd check. What did we say? You reflected and translated?
Yeah, times each 6 units and then reflect. That's right, Emma?
Yes.
So this thing comes down here. See,
That's 6
you come down here. Yeah, you're 3 away. You're 3 away. 1 away. Okay, yeah. So I would translate, like they said. What happened? Translate and then reflect.
Does it matter like what order you put it?
That is, you might reflect it this way and then translate it.
Yeah. No, like.
Whichever one you would do first, you have to write that one as
But
first.
is it wrong if you do it in different order?
No, if the picture lands the same. So it is also true, which is a good point.
So it doesn't matter.
You could go this side first. You could translate it this way. You can reflect it this way,
Yeah, that's
and then translate it down. Uh-huh. Well, translate can go in any direction as long as it's the same pictures. Like if you have pictures, oh, your phone, say you're looking at your phone on the table, hey, move your phone, I don't want to spill my drinks on it. You move it over, you just translated your phone. If you moved it up, down, left, right, doesn't matter which way you moved it. To reflect, it changed. Yeah. So translate just means to jump. I know. I'm going to go turn it on right now. I'm translating right now. I'm translating to the left. One up. Connect the dots. What is this guy? He's a B prime. Take a look at what I did. See? Circle the 1, minor step, go up 3, over 2, 1, 2, 3, 1, 2. Second dot. Get 2 dots, connect the dots. You have your first line.
She made us do a,
That's not how you did it.
It's okay. Well, do this. Listen to what I say. See which one you like better. Use that. There it comes.
But it's like a completely
Once you get your first line, once you get your first line, get your paper.
No, it's because she made
Up, it's positive, down. Get your paper for me, please. Get your paper. Oh, give me paper. Push that back door. Push that back door. Someone push that back door. Get your paper. They're going to actually translate it up. In this case, 2. You're going to cover it. You're going to draw the picture. Draw the y-axis. And then slide it up. This point here. This point here. Draw it, and then you're going to move it up 1 to the paper itself, because you also have to redraw the line again. I'll do it over here. Pause. Here's some information I'm going to say to you that'll be important, but I don't think I've mentioned ever before. This triangle, because the 2 walls are the same. Anybody know the name of it? Yeah. Isosceles triangle is what this is. What do you know about the base angles of an isosceles triangle? Anyone?
They're either super cute and inside.
What's important? These 2 little marks that I want you to put on your paper, they are equal. Write this down, please. Yeah. If you want. Base angles are equal. Ooh, let me put the word they're going to use. I'll put equal. In parentheses, I'll put congruent. Just in case they use that word. Congruent. Now, for some of you where there's going to be too much information all at once, you'll get to fix something on your test that is broken. What you got? 2, half and half, no big deal. Let me erase that line so you don't mess up on the second one. Well, if I were to draw this line here, okay, that kind of cuts it in half. Yeah, same thing. So far there are 2 lines that I discovered. You almost have to ignore this one because this one here, different color, this one here cuts it in half. Hopefully you can see that. This one here cuts it in half. Hopefully you can see that. This one here cuts it in half. This one here is terrible. If you get enough of them, I'll be like, I think they get it. Even if they missed this last one, they get that every time they draw a line, they have to be able to see, like, would it fold on top of each other? That's technically the easy part.
What if we miss one line?
Right, I'll give it to you. And over here, they're showing what they usually look like. These are lines of symmetry. On popular items, chances are you may see one of these guys. There's one of them that doesn't have a line, though. Anybody know why that last guy doesn't have a line?
Because Campbell didn't have.
Even if you go corner to corner like this? I wish I could fold this thing. But it is true. If I were to fold it, this little piece here, he would wind up like kind of up here, not landing
What
on
about the other way?
the other way. Let's try it.
You can't do it, Adam.
Okay, I'm sorry.
You can try.
I'm just wondering.
As hard as you try. Yeah, it will come up over here and over here. So it won't fold onto itself.
Okay.
There has to be at least one where it doesn't work, so be careful which one it is. All right, so first thing, hey, how many lines of symmetry do I have here? 1, 2, 1, 2, 3, 4. 1, 2, 3. I wonder. No, that's not. I was gonna say, I wonder if it's the number of sides. I thought there was a pattern, but here, 1, 2. I don't think you do. You just draw the lines. Here comes the other part. That's the part that's tricky, and this is the last thing I'm gonna share, and then you'll take. Does this triangle have rotational symmetry?
No.
This one should, and the way you know it is this. If you have your paper, you would draw. You would draw the triangle on top on the paper. This is the easy part. This is the yes or no part. It's the number part that most students lose the points on. So you put your paper on top, no big deal. You redraw it. By the way, on the original picture, you do have to put a dot right in the middle. That dot is very important because on your tracing, that's where the dot is going to go. So that with your pencil, you can hold the paper so you rotate it, and if it falls on itself again before 360 degrees, like it would have worked. So boom, it falls on itself again. So the answer is yes. This triangle has rotational symmetry. Hey, how about that square? Yes. So
Danielle told us
yes.
she told us the top two, the last two, and then the one over there and the one over there.
This is one case where I would put what I'm saying on the test. And when she raised your test, which she won't, she said, why did she do
No,
it?
Yeah, she did. She was saying that you couldn't cut it, but it's not that you can't cut it on. You have to like flip it.
Oh, yeah, because on our paper, we've been like trying to cut it.
So you do need to cut. They're going to actually do both. They're going to say, please draw a line for reflectional symmetry. In other words, can you cut it in half? Reflectional symmetry.
Oh,
Then they're going to say,
that's
this is rotational symmetry. In other words, if I drew the picture,
she didn't know that.
yeah, and I rotate my paper, will the picture fall onto itself, is one way they say it. Will the figure map onto itself, is another way of saying it. There's one other way of saying it, but the rule is, when I rotate it once, does it do it? If I, let me put the original. I'm going to put a big dot in the original corner, so you can see it happens more than once. And this is the part that you'll need. Here goes. I rotate once, bang, oh, it does it once. I rotate twice, bang, it does it twice. I rotate again, bang, it does it a third time. The last time where it brings it back into the original, we don't count that. We don't count bringing it back to the original. So here comes the question. Hey, Thomas. 1, does this square have rotational symmetry? Yes. How many times does it do it? 3. Here comes the 3, so you can see the 3 again. 1, 2, 3. You don't count going back to the original, so that guy is not a 4. He's 3. I wish that was the end. It's not. The last part is you have to give some numbers. You have to give numbers for 1, for 2, and for 3. What the heck? What does it mean? Give numbers for 1, 2, and 3. It's just timetables, and you will have your calculator. It's just timetables, and you will have your calculator. Hey, Thomas, how do you give us the final part of the answer that we're going to take in 5 minutes? And I'm sorry I saved this part to the end, because it's one of the tricky parts. Somebody with a calculator will help me in just a second. There we go. 1. I'll put my 1. 2. Does it 2 times? 3. It does it 3 times. What are the numbers I'm going to put next to 1, 2, and 3?
See if it goes out of shape.
Oh, come on, let's see if this thing will work.
Yeah.
Times. There's no way they're going to remember all this. I sure hope you can get 2 out of this section without needing this.
Should be on board then.
Good suggestion. I'll think about it. All right, so here we go. How do you know what number goes after the multiplication sign? The answer is this. It's always 360 divided by a number. What's the number that you're going to divide it by? However many sides there are on this shape. If it was a triangle, I would do 360. Oh, I apologize for this. Divided by 3. If it's a rectangle, 360 divided by 4. If it's that hexagon, count the number of sides. 360 divided by. Calculator person, please help me out. What is 360 divided by 4?
Oh, ridiculous.
Yeah.
120. I think.
90.
Okay.
I can't even use a calculator.
It's going to be in there somewhere, though. 360 divided by the 3? That's the one.
120.
Yeah, that's the one you did.
Um,
Someone do 360 divided by 6?
60.
Yeah, 60.
So that you're not completely confused. What have we done so far? 1. We figured out how many rotations can happen.
Yeah.
And what's the 6?
2. We have to multiply these 3 numbers by something. By what? By this answer here. In this case, if we were talking about the triangle, it would be with this one. If we were talking about the hexagon, it'd be whichever one we get. So it's different numbers. I'll do it anyway.
What?
I will do it anyway. Here, let's finish this thing off.
and 2 y.
90, 90, 90. All right, calculators. 1 times 90 is
90.
180.
180.
I made this
You should.
You should.
You confuse me already.
Yeah, I hope there's a 2 in this section without this, but there may not be. And if it's not that hard, I mean your message. Or just mine. All right, here's the deal. I'm about to give you the test in 3 minutes, so here's what you get to do. Of the stuff we've seen, you may want to ask a question. I'm going to slice this thing up with the lines of symmetry. I'm going to get the answer for this one, so you'll see if they put a pentagon, what the answer would look like. But while I'm doing that, you're going to be thinking like, okay, I want to ask one last question about one thing, and then you can do that. So here it comes. Hey, Thomas, I get this question on the test. Please draw my lines of symmetry in half. Oh, this is weird. It's supposed to cut here. It's supposed to cut there. All right, so how many lines of symmetry? I have that many. Hey, Thomas, does this thing rotate? It turns out it does. You just got to trust me. Like if I put the thing, it does rotate. How many times? It's always the number of sides minus 1. So in this case, since it has 5 sides, I know with my paper, click, 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 it'll do 4. First time, second time, third time, fourth time. Hey, Thomas, what are you going to multiply times 1, 2, 3, and 4? Can someone do 360 divided by 5 for me, please?
So it's by the number of sides it has, that's what you divide it by.
Yes.
So that
Again, I hope that this section has 2 problems you can get without needing this. I think it does. In other words, this will definitely be a 2 section. I'm a genius, 72. Not so much a genius. Ooh, yeah, 144. 144 twice is 288. 3. 210. 6, 216. Somebody put in 3 times 72. See if it's 216.
It is.
Oh, sweet. That makes me like sting a genius.